Hello, I'm Theo Aanhane and I'm the proud CEO of NSure. On behalf of the staff of NSure, I'm very pleased to welcome you to this 10th anniversary webinar. Today, we're celebrating that we've achieved something special. Only few startups are motivated and capable to survive. Moreover, only very few of them reach the stage of having the number and quality of customers we have. I'm very grateful and proud that NSure is one of them. It's the best proof that we deliver good and valuable results and are a reliable partner to work with. But it wasn't easy, and it's still hard work. But it's like they say, no pain, no gain. It's already 10 years since our founders, Monique van Wordragen and Peter Balk, concluded their research could be of great value for agricultural practice, and they decided to start NSure. Although the industry showed great interest, commercial results of the ripe NSure test for apple and pear didn't meet the expectations. It's always easy when you look back. However, in my opinion, the market wasn't ready yet for such innovative tools. But how many of you know that their first test, called NSure for tree seedlings, is still being used by a stable group of Scandinavian customers? Nevertheless, after 3 to 4 years, it was clear that the business model had to change. Next to test development, NSure started to offer contract research. And after a while it appeared that the original model of test development and contract research could easily be combined. The next step was to bring focus in the subjects and crops NSure would be working on. So we introduced our focus areas: physiological switches, early warning and bioresponse. And here's where we are today. We've managed to develop a number of commercially available and reliable tests, like Fresh NSure for apple, Bloom NSure for viburnum and hydrangea, Cold NSure for tree seedlings, Store NSure for carrot and strawberry, and our most recent success, Break NSure for kiwi fruit. We are collaborating with many producers of agrochemicals and biostimulants to provide insight in the mode of action of their products and to enhance their product development. Still, we're being surprised by the opportunities of our powerful technology. Today is a very special moment for NSure, not only because we've reached the age of 10 years, much more because we have become a recognized partner for a large number of relevant players in the industry. As a present to you, our customers, we've made this webinar. During the next 20 minutes, Peter Balk will provide some backstage insight in our technology. Then, Dr. Frank Huberits, one of our senior scientists, will show examples of successful partnerships and valuable applications of our technology. And finally, NSure's lab manager, Chris Roelofsen, will show you how NSure discloses powerful information from just a single drop of plant juice. You could even ask your questions directly using the private chat option. I hope you will enjoy our present.
Hi, I am Peter Balk, one of the founders of NSure and technical manager of a team of excellent molecular biologists. Already from the start of NSure, we are entirely focused on gene activity measurements. Me and my team are convinced of the added value of agriculture. Why? Before any visible effect of changing conditions can be observed, genes have changed their activity already. So focus on these early changes opens the possibility to act before it's too late. Measuring gene activity simply means being in time. Throughout the life cycle of a plant, gene activity is changing continuously and massively. Each quality characteristic of a plant or plant product is, however, controlled by specific genes. Today, it is possible to study the activity of all genes simultaneously in all crops. Differences between different situations can be studied in detail. Not a single change in gene activity escapes from being noticed. The challenge is select those genes that are relevant in a specific situation. Once you know what gene activities are informative, you can act on that just by measuring them. Identifying such genes is the expert knowledge of me and my team. Start thinking about our approach, and soon you will reveal endless possibilities. So that's why we need focus. We at NSure at the moment concentrate on 3 different areas, of which the first one is physiological switches. Important tipping points in plant development can be recognized clearly on the gene activity level, such as reaching full hardiness towards low temperature, or reaching the moment of entering or breaking dormancy. Early warning is the second one. Long before visible symptoms of a disease become apparent, changes in the activity of resistance-related genes can be observed. In this area, NSure developed a molecular test for carrot. Early signs of black spot disease, a destructive disorder in long-term stored products, can be measured. And this at the moment where from the outside the carrot is still in perfect shape. Besides carrot, we studied early responses in tomato, strawberry tray plants and some ornamentals. Our third point of focus is bioresponse. Crops are treated with numerous agents in order to secure maximal production. A special group of these agents forms the so-called biostimulants. Studying effects on gene activity of such agents explains their mode of action. And even better, once genes can be selected that specifically react on the applied agent, they can be used as a tool. Try, for instance, a new formulation and quantify the effect using these genes, or find out in what stage the plant is most sensitive for the agent. Within a moment, my colleague Frank will give you 2 examples where we definitely add value using our technology. And I do hope that at the end of this webinar, you will be as convinced as me. Even better, that I can start a discussion with you to look for applications that can be beneficial for your business.
Hi, I'm Frank Obrechts, researcher at NSure. I've been working at NSure for 6 years, and my role within the company is focused on test development and contract research. A good example of a test that we've recently developed is the break-and-show test for kiwi fruit. This test was commissioned by Zespri, a company that is constantly trying to advance the New Zealand kiwi fruit industry through innovation. Our test provides kiwi fruit growers with a tool to determine their optimal moment of application of bud break enhancers. Bud break is a crucial step during the cultivation of any fruit, as optimal bud break is the first step towards an optimal harvest. In our trials, we saw indeed that the result of a treatment greatly depends on the time of application. We then identified genes that make it possible to recognize that optimal moment of application. And these are the genes that are now being used in the test. Our customers can do the sampling themselves because of our easy NSure sampling method. By working with a local lab, we greatly limit turnaround time. And since we work with a local distributor, we are able to reach potential customers all across New Zealand.
Hi, my name is Mary Black. I'm an innovation leader at Zespri International. We've been working with NSure on the Break NSure test since 2014. A key component to kiwi fruit productivity is achieving high and even production of shoots and flowers in spring, and we use bud break enhancing products to help achieve this. There are opportunities to sustainably improve kiwi fruit orchard productivity if we can optimise the use of these bud break enhancing products. Therefore, we were looking for an opportunity to improve application of bud break enhancers. We chose to work with NSure as they were able to demonstrate to us that they had the capability to develop the test we were looking for. They have experience in developing tests that look at the physiological status of different crop species through dormancy. They had the knowledge and expertise that were required to do the project, and they had access to the equipment that was required. We didn't know what the genetic signal was that we were looking for, therefore having the capacity for high throughput of a large number of samples was attractive to us. We've had a really good relationship with the NSure team. They're a friendly and professional group. We've had a few challenges with time differences, with us being based in New Zealand. However, we've easily overcome these with morning and evening Skype calls. The team have been really committed to the relationship with annual visits to New Zealand. This has been a really good opportunity, not just for relationship building, but also for them to see the orchards firsthand, so they can see the plants, meet the growers that will ultimately be using the test, and to get a feel for the commercial environment. This has also been a really good opportunity for them to meet with the New Zealand scientists that have been involved in our project. We're really excited to see the Break NSure test released in New Zealand this winter. We've seen a lot of grower interest, and we're really looking forward to seeing the use of the test grow in the future.
As I mentioned before, I'm also involved in contract research. For example, for Valagro, we studied the molecular effect of a novel biostimulant on corn and soybean. Valagro is a leading company in the production of biostimulants and specialty nutrients for agriculture. It is a globally operating company that is based in Italy. We compared leaves treated with the biostimulant to untreated leaves, looking at the activity of every gene present. For this, we used next-generation sequencing, a powerful technology that allows to look at the activity of tens of thousands of genes at the same time. We found that the genes responding to this biostimulant are involved in various biological processes, such as cytokine metabolism, nutrient assimilation, cell wall modifications, and energy production. The results we obtained contributed to a better understanding of the mode of action of this biostimulant, and it helped Valagro supporting product claims. The identified genes can also be used to monitor treatments, to improve product formulations, or to optimize the timing of application.
Valagro is interested in use this technology because represent for us the natural evolution on the approach on genomic study that we started in 2007. And because with this new technology we have the opportunity to extend our investigation also on those crops for which the entire genome has been not codified, because we can have more detailed information that can enrich our knowledge regarding the performance of our solution.
And how do you feel about the collaboration with NSure?
I feel good because NSure represents for us a strategic partner, perfect aligned with our concept of scientific networking. So a team that permitted to us to work in strictly together and on a long-term project where we can apply this technology for common interest project research.
Will I be doing my next project with you? I'm looking forward to it.
Hi, I'm Chris Olofsen, Laboratory Manager at NSure. I would like to give you some insight in our lab and the techniques we use to obtain the final result. In our lab, we detect RNA molecules. And why RNA? Because when a gene is active, it produces such molecules. Before measuring the RNA, you need to extract it from the sample. To extract the RNA from the sample, NSure uses two different methods. One starts from frozen material, the other one starts from material bound to a so-called FDA paper. Let me explain these two methods. For test development and contract research, we use frozen tissue. This can be tissue of fruits, buds, leaves, etc. In all these cases, we analyze the activity of all genes. That's why we need large amounts of RNA. The fresh tissue can be directly frozen in the field at -80 or -200 degrees Celsius. This prevents any unwanted changes in gene activity in time. We stop every process at once by freezing the sample. Once the frozen sample has arrived at the NSure lab, it can be stored for a long time at -80 degrees Celsius. Regarding the other method, RNA is conserved on FDA cards. This method is used when only tiny amounts of RNA are needed for analysis. This is how it works. A fresh juice sample is made by the customer in the field. Just a few drops are applied directly to the FDA card. The RNA in the juice sample is stabilized as soon as it touches the paper. After drying the card, it can be sent by regular mail to our lab. Now, let me tell you something about the processing of the FDA cards. In our lab, we extract the RNA from the FDA card using multiple techniques. We carefully clean up the RNA until it's ready for gene activity analysis. To measure gene activity, we make use of quantitative PCR. With this technique, you can amplify specific RNA molecules. Why amplify? Without amplification, the low amount of each specific RNA cannot be measured. For every test, we measure a specific combination of RNA molecules. The combined data from the test-specific genes are being integrated into a clear and useful result. This can be an advice for cold storage, or, in case of the break and show kiwi fruit test my colleague Frank told you about, an advice for optimal application of a bud break enhancer. I hope I've given you some insight in our lab procedures and what is happening with your samples.
Here I am again. That's it for today. I hope you have enjoyed watching our webinar. You will receive a short questionnaire, and I'd like to ask you to spend a couple of minutes to provide your feedback. If you do so, you will receive a voucher for a free consult. So that should be worth it. I'm not closing this seminar before I've said thank you very much to our very competent and experienced staff for being so motivated and flexible. Thank you very much to our generous shareholders for being so loyal and persistent. And thank you very, very much to our customers for all your great questions and for relying on our capabilities to answer them. You're the reason we keep improving. It wouldn't be half the fun without you. I hope we'll meet again soon. Bye.